Hey, let's see how you did on these homework problems. I honestly can't remember if this page was the first four problems or if this one was. I'm not sure. I'm going to go with this one for now, so don't freak out. This is either problem number five or problem number one. The rest will be coming. Okay, I just want to go over these answers and see how you did and sort of reemphasize what we do when we solve algebraic equations. Okay, again, the first question I will always ask is, what is our goal? And our goal is to get that n all by itself on one side of the equal sign. Okay, it's the n here, it's the c, then it's going to be the d, then it's going to be the f. To get the letter, the variable, all by itself on one side of the equal sign. And the mathish, because you want to be able to speak mathish, you want to be bilingual, the mathish term, or mathese, if you want to say mathese, for getting the variable on one side of the equal sign by itself is to isolate the variable. And remember, what does isolate mean? You remember in third grade when that one kid was sort of acting up and he got in trouble and the teacher said, I need to isolate you, right? Or if you have a bunch of brothers and sisters, sometimes mom needs to isolate you, right? That means you got to go be by yourself for a little while, right? Time out kind of thing. Okay. So to isolate the variable is going to put the variable all by itself. And one way to remember that word isolate is to think of those letters ISLA, because ISLA in Espanol, in Spanish, means island in English. ISLA, ISLA, ISLA. Okay. So we want to put that letter, that variable, on an island all by himself. Okay. So you look at that problem, and the next question you ask is, who do I have to kick off the island so the variable can be alone? Okay, and a lot of you right now are saying, I need to kick off that 3.5, but it's not just the 3.5, it is the plus 3.5. That plus is important, that operation, what is what is going on with that 3? You're adding the 3.5, okay? Because the next question is, how will I get rid of something? How would I kick something off? Well, you do what's called the inverse operation. Now, the inverse operation, an easy way of explaining what that is to just say it's doing the opposite. What's the opposite of gaining 10 pounds? Losing 10 pounds. What's the opposite of it getting 6 degrees cooler? Well, getting 6 degrees warmer, right? What's the opposite of losing $12? Finding $12 or earning $12. Okay. So what is the opposite of plus 3 5/10? Hopefully you're saying minus 3 5/10. Okay. And hopefully now you're kind of feeling weird because you had an equation, and Mr. Daniel says that equal sign means everything is in perfect balance, and you just subtracted 3 5/10 from that side. Well, that's going to make that side a little bit light, the other side a little bit heavy. Now it's leaning to the right. How do I get it back in balance? That's where this bracelet comes in. Do the same thing to the other side. Okay, so what does that mean? If I subtracted 3 5/10 from this side, and I subtract 3 5/10 from this side, then my equation that was in balance is back in balance. Okay, so why did I do all that? Well, because again, these are opposites. You put opposites together, they cancel each other out. They go away, right? If I find $3.5 and lose $3.5, I'm back where I started. Okay, so all that will be left on that side is the n. And what's on this side? The 12 81/100ths minus the 3 5/10. I just got to go do the math now. Okay. And again, when you add or subtract decimals, you stack those decimals first, all right? One on top of another. And then when you look at it, if one of the decimals comes out farther to the right, more places, then you can fill in those places with zeros so they come out to the same spot. Okay, so now they both come out to the hundreds. You don't have to do that, but it's a little less confusing. It looks a little neater for me. All right, if you're one of those OCD guys, OCD girls, you might like the way it looks better. And then you're more likely to get it right, especially when you're subtracting. So 1 minus 0 is 1, 8 minus 5 is 3, and 12 minus 3 is 9. I have an answer. N must equal 9 31/100ths. Okay, and before you celebrate, ask yourself, if n truly equals 9 31/100ths, then I should be able to substitute 9 31/100ths in wherever I find an n. Well, in my original problem, I had n. So if I go 9 31/100ths plus 3 5/10ths, everything else I'm leaving the same. And I want to see, is this true? Okay, and how do I see if that's true? Well, I go do the math. 9 31/100ths, 3 5/10ths. Okay, I'm adding, filling a 0. So 1, 8, 12. Boom, we did it right. Shh. All right. Ding, 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 ding. Cowbell. All right, good job. Hope that didn't hurt your ears. All right, so 1 down, 7 to go. I'm going to go through these next few a little bit quicker. Okay, what's my goal? Hopefully you said isolate the variable. Okay, what do I have to do to get the c by itself? I have to get rid of a minus 2 4/10ths. How do I do that? I use the inverse operation. What is the inverse operation for minus 2 4/10ths? Hopefully you said plus 2 4/10ths. But Mr. Daniel, this is out of balance if you do that. I just added 2 4/10ths to one side, so now it's leaning this way. How do I get back in balance? Do the same thing to the other side. Okay, and remember, these are opposites. What happens to opposites? They cancel each other out. All that will be left here is a c, and I have c equals 18 200ths minus 2 4/10ths. Let's see what that is. Stack them. This is, sorry, that's plus, isn't it? Whew, good catch. Good catch. Would have figured out it was wrong when I substituted, huh? All right. Nice thing about doing that. So I should get 20 42/100ths. Now, if that is true, we're always going to go check. I should be able to substitute and say 20 42/100ths for C minus 2 4/10ths should equal, if I did this right, 18 200ths. Okay, I'm going to do that over here. Got a little bit more room. Stack, subtracting 2 4/10ths. Fill in a 0. 42 minus 40 is 2. 20 minus 2 is 18. Boom. Cowbell. Woo! Buggers. Good job. All right, next one. What is my goal? Isolate the variable. What's going on here? 16d, what does that mean? That means 16 times d. Now, the first thing I do is I put the variable first. It's a little less confusing for me, and it also allows me to put the inverse operation together. You'll find that out later. So d times 16. How do I get rid of that times 16? I do the inverse operation. What's the inverse or the opposite of times 16? Hopefully you said divided by 16. But Mr. Daniel, it's out of balance. How do I stay in balance? Put on the bracelet. Same exact thing to the other side. If I divide this side by 16, I should divide the other side by 16. I don't know if you guys notice, whenever I do the inverse operation, I do that in another color ink. You don't have to do that, but it's kind of cool when you do, when you go back and relook at your problem to see how you got there. Okay, you see it sort of stands out, and I think it helps you learn it a little quicker. So if you have another pen, you might try doing that. Only do the inverse operation, do it on both sides, right? You want to see it in balance in another color ink, and I think that helps. So times 16 divided by 16, they cancel each other out. All that's left on this side is D, and on this side I have 76 8/10ths divided by 16. How many times does 16 go into 76? Well, the decimal comes straight up. I think it goes 4 times, because 4 times 16 is 64. And how many times does 16 go into 28. That's going to happen one time. And how many times does 16 go into 120? Let me see. 6. Looks like 7 times, right? Yeah, 7 times. It's 42. And if I add another 0, I'm going to get lucky because 16 goes into 85 times. That was hard just because the math of it was hard. Dividing 5 or 16 into 76 and 8/10 was it took a lot of steps, right? Because I had to keep adding zeros. Okay, now if this is true, I should be able to substitute and say 16 times 4.175, 4 and 175 thousandths equals 76 and 8/10. And if that's true, 4175, 4 digits. Yeah, this is a tough one. 30, 42 and 3, 45. 6 and 4 is 10. 24 and 1 is 25. Put a placeholder, cross those out so I don't get confused. 1 times 4175 is going to be 4175. Go add them. And what do I got here? I have a problem. Houston, we have a problem. So 16, I got 66.8 instead of 70. So let's just double check. 6 times 5 is 30. Carry the 3. 42 and 3 is 45. Carry the 4. 6 and 4 is 10. Carry the 1. 24 and 1 is 25. And it looks like I did the math right there. So I think I made a mistake here. I don't think that's the answer. We're going to go divide that again. Now, when I recheck something that I've done wrong, I usually go do it on the back. Okay. So 16 into 76.8. Okay. And this is real life. This happens. Mr. Daniel, especially when he hurries, makes mistakes. Now, I know 4 times 16 is 64, so I'm still going to have this part right. Okay, but this is 12. I think I just brought down the 2 last time. Let's see if I had a 28 or 128. That's where I went wrong. I rushed when I subtracted. I only put the 2 down, so I thought it was 28. It says about 128. 128 that's a whole different thing, right? Because 8 times 16 is 8/10s, 80, and 8 6 is 48. What's 80 and 48? Okay, so 4.8 should be my answer. Let's fix that. Boy, aren't you glad we double checked? What if this was a test? We would have lost some points, right? Unless you double checked. So this should be 16 times 4.8 equals 76.8. And let's go try that. Pretend like there's no decimal. 6 times 8 is 48. 24 plus 4 is 28. Put a placeholder. 1 times 48 is 48. 8, 16, 1, 2, and 4 is 7. Now, this was really 4.8, so I went over 1 spot in my problem. I got to go back 1 spot in my answer. Whew. Got it. All right. Yeah. Yeah. Real life. That happens. People make mistakes all the time. That's why you always want to double check. You know what carpenters say? Measure twice, cut once. Right? Right? Measure twice, cut once. We always sort of double check things. All right. On to this one. F \4. What does that mean? The first thing I'm going to do here is I'm going to rewrite that as F divided by 4. It means the same thing, but this way, for me anyway, seems to be a little easier to solve. Now, what is my goal? Isolate the variable, right? So that means I want the F all by itself down here. How do I get the F all by itself? I have to kick everything else off the island. I have to kick off a divided by 4. How do I do that? Inverse operation. What's the inverse operation or opposite of divided by 4? Times 4. But you'll be out of balance if you only multiply this side by 4. You want to multiply both sides by 4. Remember, every equal sign is a balance. Everything is in perfect balance. Okay? So I got the times 4 on both sides. Now this divided by 4 and times 4, they are inverse operations. They're opposites. They cancel each other out. All that's left over here is what I wanted, that f. And all that's left on this side is 8 4/10 times 4. I multiply by pretending it's 84 times 4. 4 times 4 is 16. And 4 times 8 is 32 plus that 1. 33, and I moved over one spot in my problem, so I gotta go back one spot in my answer. I should get 33 6/10 for my answer. How do I make sure I got it right? If f equals 36 6/10, I should be able to substitute 33 6/10 into my problem and have something that's true, okay? So 33 6/10 divided by 4 should equal 8 4/10. Let's go try it. 33 6/10 divided by 4. Remember, the decimal comes straight up when you're dividing, and the decimal is inside that box. Now, 4 times 8 is 32, so I'm going to put an 8 there and bring down the 6. And how many 4s fit into 16? 4. And I'm done, and that's what I got, 8.4. Boom. Plug your ears. Here comes the cowbell. Woohoo! Good job. Okay, halfway home. Hopefully these next 4 won't take as long. Again, I'm going to leave this here so we can see what we wrote over here. What's my goal? Isolate the variable. What do I have to get rid of to get that x all by itself? A plus 6 1/100. How do you get rid of a plus 6 1/100? Inverse operation, or opposite. What's the opposite of plus 6 1/100? Minus 6 1/100. But you had an equation, it was in perfect balance. You just subtracted 6 1/100 from this side. It's a little bit light now. It's kind of up like that. It's leaning to the right. How do I get it back in balance? Do the same thing to the other side. Okay, again, those opposites cancel each other out. All that's left over here is x, which was what I wanted. And on this side, I just have a little math problem. A little bit of subtraction happening, right? Line up those decimals. So I put that 14.7. I'm going to put the decimal in that 6 0 1/100, right? First, now, again, this is one of those areas where it definitely helps you to add that 0. If you don't add the 0, people are really tempted to bring that 1 straight down. Well, I'm subtracting. I'm supposed to take that 1 away from something, okay? I'm taking it away from 70, okay? So I had to borrow, you're going to get 69, right? The decimal comes straight down, and 14 minus 6 is 8. So I get 8 69/100. How can I make sure that I got that right? Because I always want to double check, right? Well, I'm going to substitute. If this is true, then 8 69/100 plus 6 1/100 should equal 14 7/10. Does it? Well, let's go see. Now, both of these came out to the hundreds place, so it was a little bit easier to line up the decimal. 9 and 1 is 10, carry the 1. 1 and 6 is 7, and 6 and 8 is 14. 14.70, that is the same as 14.7. Okay, boom, boom, boom. Plug your ears. Woohoo! Good job, you guys. All right, what is my goal? Isolate the variable. What does that mean? A all by itself. What do I have to do to get the A all by itself? I have to get rid of something. Am I getting rid of the 4.36? No, I'm getting rid of a minus 4.36. How do I do that? I do the inverse operation, or opposite. What is the opposite of minus 4 36/100? The opposite is plus 4 36/100, but I will be out of balance if I do that, right? If I add 4 36/100 to this side, I'll be out of balance, unless do the same thing to the other side. Okay, now again, these opposites, what do? They cancel each other out, so all that's left is A, what I wanted. On this side, I have a small math problem, 21 5/10 plus 4 36/100. Let's see what that equals. Stack them, line up the decimals, fill in zeros to make it a little bit less confusing, bring the decimals straight down, and I get 25 86/100. Now, if that is true, I should be able to substitute 25 and 8600ths. If that's what A equals, then I can put that in for A, right? Let's see if we did it right. Let's go double check. 25 and 8600ths minus 4 and 3600ths. Didn't line it up very good there. 6 minus 6 is 0. 8 minus 3 is 5. Well, I didn't really have 4 is supposed to be on that side, huh? That 4 is supposed to be on this side. So 25 minus 4 is 21. 21.50, which is the same as 21.5. We did it right. Plug your ears. Here we go. Woohoo! All right, 2 left. What does 6p mean? It means 6 times p. Go ahead and put that time sign in there, and then I do that extra step. And it doesn't end up being an extra step because I leave a little space for the inverse operation. But I rewrite it as p times 6. What is my goal? Isolate the variable. How do I isolate the variable? I get rid of everything else. I kick everything else off the island. What does the p need to kick off the island? Not just a 6, but times 6. How do I get rid of a times 6? Inverse operation. What's the opposite of times 6? Hopefully you said divided by 6. I'll be out of balance unless I do what? Do the same thing to the other side. Okay, I did the same thing to the other side, and now these two things cancel each other out. All that's left is p. And on this side, I have 49.2 divided by 6. How many times does 6 go into 49 and 2/10? Well, the decimal comes straight up. 6 times 8 is 48, right? Bring down the 2, and 6 goes into 12 twice. Boom. 8 and 2/10 should be my answer. How can I make sure? Substitute. If that's true, 6 times, instead of p, I'm going to write 8 and 2/10 should equal 49 and 2/10. Let's go see if it does. Pretend there's no decimals. 6 times 82. 12 carry the 1. 48 plus 1 is 49. But I had to move the decimal over one spot to pretend that was 82 instead of 8.2, right? So if I moved it over one spot in my problem, I've got to move it back one spot in my answer. Boom, boom, boom. Did it right. Okay, plug your ears. Woohoo! All right, last one. M\5. I know my goal is to isolate the variable, get the m by itself. But what does that mean, backslash? Hopefully you recognize that as being a division problem. Okay. How do I get rid of a divided by 5, right? I do the inverse operation. What's the opposite of divided by 5? Times 5. If I multiply that side by 5, I want to stay in balance by doing the same exact thing to the other side. Now, these are opposites. They cancel each other out. All that's left here is m. On here, I just have a math problem. It's no longer algebra. It's just math. 248 times 5. 8 times 5 is 40. 5 times 4 is 20, plus 4, 24. And 10 plus 2 is 12, but I moved the decimal over one spot to pretend that was 248. I got to go back one spot in my answer, 124. Now, if that is true, I should be able to substitute 124 in for m. And 124 divided by 5 should equal 24.8. Let's see, 124 divided by 5. 5 goes into 12 twice because that's 10. 5 goes into 24 almost 5 times, but only 4, huh? 4 times 5 is 20. Now, I have a remainder, so I'm going to add a decimal and bring it up, add a 0, bring it down. 5 goes into 40 how many times? I already said it, huh? 8. You heard me, huh? You heard me say that? Ha! 24.8. Okay, plug your ears. Here it comes. Yeah, extra special out on that one because you are done. How did you do on your first homework assignment of solving algebraic equations? Hopefully well, okay? These are hard. Take it slow, one step at a time. Slow is smooth, smooth is fast. I talk fast sometimes. This is still a long video. All right, have a great day, everybody.